Hey everybody, this is Brian and welcome to part 2 of our user feedback, how to use a third-party DLL and encrypt a file. Okay, what you're looking at is the remnants of our last tutorial. If you didn't watch it, you need to go back and watch that, because we discussed how you grab the botn library out of the Qt Creator source, and we have compiled and replaced the botn DLL with the A files. That's so you actually use the MingW compiler on these, not the Visual Studio compiler. Alright, let's jump into Qt Creator. Go new project, console, and we're just going to say botn test 1. Put this in the usual location. Next, finish. Alright, now the absolute first thing you need to do is you need to link to that library. Now how do we do that? Well, you need to modify your project file. And to do that, you just go, if I can spell, include path, and you want to say plus equals, and then you want the path to botn, where you installed it. So we're going to say, botn / include. And what that'll do, let's jump back into the botn libraries here. You see this include subfolder, there's botn, and then here's all the header files that we need in order to work with those DLLs. So that's our include path. That tells the Qt Creator where to find those header files. And then we want to actually have the library. So you're going to say libs plus equal, and then of course we're going to give it the location of those A files that we created. And what that does is that tells Qt Creator, hey, these are the library locations we're going to use. You're going to link to this .a file. Alright, at this point, let's save your project, and then let's just go include botn and botn h. Let's just try to link to this library and see if we can actually have a successful build here. And sure enough, it built. Now, at this point, you should stop. If you get a bunch of errors and it says unresolved reference to undefined symbol, blah blah blah, you need to go back and follow the previous tutorial where we actually compiled the botn library and copied and replaced the DLLs in C drive botn. Now, if you try running this application, it's not going to work. The reason why is we need that botn library in the same location as our executable. So let's go out to C botn, copy that. And then we need to go to our location where we compiled this. What do we call this? Botn test. So there's botn test build, and we're in debug. See, if we try to run this, it's going to give me a bunch of missing libraries. Let's paste that in there. Now, when we run our application, it runs just fine because we've compiled and linked to the library, and it's also in the same directory, so that your operating system can find it. Now, you should note that there are more than one way to skin a cat, as it's called, and I'm sure I'm going to get a couple of you experts out there that are going to tell me, Brian, libs plus equal is wrong. You should do one for the path and one for the library name. That's the correct cross-platform way of doing it. So do check the Qt Creator documentation on the way to do this for your operating system. But if you're following me on Windows, it should work just fine. Without further ado, let's start working on how to encrypt a file. And this is going to be a fairly lengthy tutorial, and you'll have to forgive me. I may have to actually pause it a few times, but we'll get there. So, alright, let's include, and we're going to add a qdebug. And botn is not made with Qt. That's why this is a fairly advanced tutorial. We're working with the C++ standard library, so we need to include some things from the standard library. So we'll say we want fstream. Fstream, I believe, allows you to work with files. Then you want iostream. That's your C++ standard type library input-output. And then we want, of course, the include string from the standard library. Include, and we want vectors. If you don't know what a vector is a lot like an array in the sense that it's a collection. You can add things to it. It's kind of like a queue list if you're used to Qt. Include, and of course we want C-string because it uses the C library, and then include and we just want memory. If you're wondering where I'm getting all this information from, go out to the Botan website and read their reference manual. Let me actually go back to the main page here. Reference manual, and you can actually go and download the source code. Let me see here. It's in here somewhere. Current development. Yeah, source right here. Download the source code, and they've got a very, very nice API tutorial. Allows you to really get to know the nuts and bolts of this library. Okay, now that you've added all these includes, it's probably a good idea to save it and build, just to make sure you get a successful build. And if you have any linker issues, you're going to have to resolve those before we continue. So, quick review. You're going to need to link to the Botan libraries and use botan.h. And then you're going to need to use the Qt QDebug, and along with the standard library fstream, iostream, string, vector, cstring, and memory. Now, if you're wondering why we need all those, it's because Botan's written in C++ using the standard type library. It does not use Qt. Qt uses Botan, which is why you have the source code for it. Alright, now let's get cooking on this thing. And let's just say QDebug. We just want to know what's going on with our code, so we'll say starting Botan. And then we're going to have to actually make a file that we're going to encrypt. So choose a file that you don't really care about. I'm going to pause the video. I'm going to go find a file I don't care about and put in a location that I'll be able to find. Okay, I have my test file set up. I put mine in etest/zzz, just for the sake of argument, and I call it plaintext.txt, and the contents of this is just the botan bigint.h written by Jack Lloyd, the guy who created Botan. Really, you just need a file to play around with. Don't use an important file, don't use a critical file, just some random file. Actually, a good idea to create a file specifically for this test, because you don't want to lose information. Alright, now let's jump back here. So we need to say string, and we're going to call this file plaintext. Plaintext means it has not been encrypted yet. And we're going to go back to our directory here. Rename this. That way we can just do a little copy and paste magic here. And remember, you have to do double slashes or it treats it as an escape character. So now we have our file set up for plaintext. And now we want two more files, one for encrypted and one for decrypted. And these don't exist yet. So we're going to name these appropriately. Now that you've got these files set up and ready to go, we can actually start working on the encryption code. Now, the first thing you're going to need to do with Botan is actually initialize it. If you've read the documentation, which I hope you've kind of browsed through it, you know that you need the library initializer. And you need that because Botan has some things that need to be in memory when we're working with it. Otherwise, you're going to get all sorts of weird issues. And then we need to set a passphrase. We'll say string passphrase. And this is the password we're going to use to encrypt this with. And in a real-world application, you would obviously use something a little stronger than that. And what we want now is auto-seated. IntelliSense doesn't want to work here. Let me just copy and paste this here. Auto-seated, and what we're going to do is we're going to initialize a random number using the Botan library. Go ahead and give it a quick build, just make sure. Yeah, see, as I thought, we have some issues here. String is not declared in the current scope. Yes, we forgot a step, didn't we? We forgot something very simple here. We need to use the namespaces. Silly me. Alright, so what we need to do is go up here. Use the standard type library namespace, and we're going to use the Botan namespace too. And what this will do is keep us from having to use namespaces in our code. So we technically don't need to go button, namespace initializer. We just do library initializer. Now give it a good build just to make sure everything's set up so we don't have to troubleshoot any of that later on. Alright. Now let me look through my notes real quick here. Yes, the next thing we need to do is we need to set up the string to key function. And that's part of the button library. So we'll say s2k pointer and we want get underscore string to key. Now what is a key? A key is used to encrypt with. If you know absolutely nothing about encryption, what you're going to need is a key and an initialization vector. And we are going to use this SHA-256 for the key. And what that is that's a hashing algorithm. If a lot of this seems way over your head, don't worry. You don't need to really know the details. You just need to know what sort of code you're going to have to put in here in order to make this work. So S2K, or string to key, basically turns this password into our key. Now what we're going to do is we're going to take that and we need to set a few iterations. And this is just for randomizing the data. And part of the documentation for button just says use a number like 4096. If you're wondering where I got this information, I'm pulling it almost directly out of the button manual. So there's very, very little voodoo magic going on here. We want to create a secure vector, and that uses a byte. And like I said, if you're just kind of sitting there scratching your head going, what in the hell are you typing, buddy? And you have no idea what I'm doing, don't worry. You don't really need to know. You just need to follow along. Whoops. I'm going to call this key and IV. Just need to follow along and basically understand that we're using code in another library. So what we're going to set up now is the key and initialization vector. And I'm going to just copy and paste this out of the manual here for button. Kind of explain this as we go. So what we're saying is we want a secure vector, or similar to an array, of bytes. And we're using the string to key out of button to derive the key, or we're going to actually create the key from the passphrase. And that's going to essentially just turn our string, my password, into a secure vector of bytes. Now, the reason why this is an advanced tutorial is because you have to kind of step into somebody else's mind for a little bit. Jack Lloyd is a very smart man, and he has studied encryption for a very long time. That being said, I don't understand a lot of what he's done and why he's done it. I just know that his library is very, very efficient. So now we need to make a symmetric key. Because we're using symmetric cryptography, we're going to use AES-256, which is an extremely strong algorithm of encryption. It will take hundreds and hundreds of years to break it. So we're going to make the key, and we want to use the key and initialization vector we just set up, and we want to say 32 bytes, or I'm sorry, 32-bit. Now we need to make what is called the initialization vector. And we're going to just call this IV. And we're going to say key and IV plus 32, 16. If you're wondering what all of this is, what are these magic numbers? Well, 32, that's the key space, or the size of the key. It doesn't actually use my password. It converts it into this vector, and this vector is filled with information. And from that we derive a key. And think of a door with a lock. You need this key to open that door or to encrypt or decrypt the file. The initialization vector basically says, okay, initialize it in a manner that the key is slightly different every time you use it. And that's not 1,000,000% true, not even 100% true, because you would need to use what's called a salt. Yes, If you're used to Unix, you know what a salt is. And what a salt says is, if you use the same password twice, it randomizes the initialization vector to the point that the secure vector is different. So if you use my password twice, those two vectors should be identical, but a salt actually randomizes it so it's not. Makes it incredibly, incredibly strong. Not going to cover that for this tutorial. It's all in the bottom documentation. Fairly easy, fairly straightforward. What we're going to do now is just do a simple build, make sure we get a good build going on here. So now we are ready to actually encrypt our file. So we need to make a function for encryption. So let's just jump back up here. And we're just going to say void encrypt and we're going to need some information here. We're going to need the symmetric key, the initialization vector, the name of the file we're going to encrypt, and the name of the file to be encrypted. So what we're going to do here is we're just going to say symmetric key, and we're going to call it key, initialization vector, we'll call it IV, and then we need a string, and we'll call it infile. And let me check my notes just to make sure. Oops, no, I called it in file name. If you're wondering, yes, I did write this tutorial out once before just to make sure it actually worked. That way I'm not, wasting precious time here. So that is our encryption function in all of its beauty, but it doesn't really do anything yet. We're going to just jump back down here and we're going to encrypt, and we're going to use our key, use our initialization vector. I'm going to say file plain text because that's the file we want to encrypt, and the output file should be file encrypted. So we're just going to encrypt a file there. Give it a good build, make sure nothing's really changed in the background. Good. Now what we need to do is we need to create some file streams because we're going to need to read from those files, and then we need to set up what's called a pipe. Botn uses a series of pipes. And what does that mean? Well, Botn is extremely powerful in the sense that you can do multiple actions and chain them together all at once. So we're just going to make a IF stream, and I'm just using the standard type library namespace just for clarity so you see where I'm getting that from. And we're going to say infile, and we want C string because we have to convert that to a C style string. And iOS input output system, and we want binary. And what we are doing is we're telling it that the file format should be read in binary. We do that because if the file has certain characters in it, they'll actually be treated as escape characters like a tab or a hard return or something like that, and that'll mess up the information in there. So we can just take this, copy and paste, and instead of an in stream we want an out stream. And we want to give it the, you guessed it, out file name here. And once again, we're telling it it's a binary file. That way, we don't get any nasty escape characters. I actually ran into that problem when I was making this tutorial, and it was pretty tricky for me to figure out what was going on. Now we want to make a pipe. Remember, a pipe in Botn is just something that we're chaining together. And we're going to get, whoops, we're going to get a cipher. A cipher is an encryption method, basically all we're doing here. And then we have to tell it what type of cipher we're using. And we're going to use AES 256. And that is the Reindel block cipher. We're going to use cipher block chaining mode. If you have no idea what any of that is, don't panic. AES stands for Advanced Encryption Standard. We're using 256 bits, whoops, not 65. 256-bit encryption, which is incredibly strong. Cipher block chaining means it encrypts a block of it and then uses portions of that block to encrypt the next block of it. It is an incredibly strong algorithm, very, very potent. The military uses it, among other things I should mention. And we're just going to set this to encryption mode. And now what we need to do is create a data sync. in Bottom, what you can do is you can say, instead of sending it to another stream or a portion of memory, just flush it directly down to the disk. So we're going to say new data sync. Oops, data sync stream, and we want out. Just not happy with that. Let's figure out what we did wrong here. Yes, I have just simply one too many of those. There we go. So, in short, let's review very quickly, because I understand this is the heart of the tutorial and you need to understand this part. We're making an in-stream using the standard C++ namespace. Yes, you could grab this using Qt, but for simplicity's sake, rather than converting the data back and forth, we're just going to grab it using the standard type library. We need an output stream. Notice we got our input file and our output file. We're creating a pipe. That's a Bottom convention. And what a pipe does, if you flip through the documentation, is you tell it, okay, perform this action, and we're getting a cipher. And we're going to use advanced encryption standard, 256-bit cipher block chaining mode. We're giving it the key and the initialization vector. Remember, the key is your password, and the initialization vector says randomize it a little bit. We're encrypting the data, and we're giving it a data sync stream. And what that is, that's a Bottom convention that says, okay, flush this out to disk, where do you want it? And we're saying out. Remember, whoops, that's why it doesn't make any sense to you. Out is the name of our output stream. Now, the neat thing about pipes is you can do multiple things with them. So we're going to say pipe start message, and then we are going to say in pipe. So we're just going to shove the information from that pipe into the input stream, and then we're going to say pipe in message, and that will, of course, finalize the encryption. Now we want to flush the stream and close it. And then we're going to just add a little marker here saying Qdebug. We want to know where we're at in the code, so we're going to say encrypted. Alright, go ahead and give it a good build. Make sure you don't have any issues. If you do, go ahead and resolve those before we continue. And you see we have one file called plaintext. When I open it up, it is the bigint.h from Jack Lloyd, the guy who invented Bottom. And we're just going to run this and see what happens. You're going to see it says starting Bottom encrypted. And when we go back out to our directory, we now have a new file called encrypted. And when you open that up, it's a whole bunch of gobbledygook, because that's encrypted using AES 256-bit, which is an extremely, I cannot stress to you how strong that algorithm is. Okay, it's probably, brutal overkill for what we're doing. But now we want to be able to decrypt that file. Don't worry, very simple. Take your encryption function, copy, paste, rename it to decrypt, and then instead of encryption, you guessed it, decrypt. Whoops, sorry, decryption. See, I told you it was going to be simple, and then I lied to you. So let's copy and paste this code. There we go, decryption. So we're just doing the inverse, and you could do all this through one function and add an extra parameter, but I'm just showing you that it's literally the same thing. You're just changing the encryption to decryption. And then you can quite literally just do this. We're going to copy encrypt, call it decrypt, and we want to take the input file is our file encrypted, and then you guessed it, or I'm sorry, yes, got a little ahead of myself there, and our output file is going to be file decrypted. So first thing we're going to do is we're going to encrypt the plain text into file encrypted, then we're going to decrypt file encrypted into file decrypted. Sorry, file encrypted to decrypted. You understand what I'm saying. Getting a little tongue-tied here. Give it a good build, make sure it works. And It says encrypted twice because we never changed that. Let's jump back up here into our decrypted. I need to learn to slow down in these videos. I get a little excited when I'm trying to show you guys stuff. Okay, now starting button, encrypted, decrypted. And when you go out to your directory here, you now have your plain text, your encrypted, and your decrypted. And your decrypted, of course, is exactly like your plain text. Just to prove that this works, let's just delete these two files. Keep your plain text. Let's run this again. Encrypted, decrypted. Here's encrypted. Looks just like random junk. And here's decrypted, back to plain text. So that's how you use a third-party library, and we're using the bottom library, and that's how also another user feedback item I've been meaning to get to, how to encrypt and decrypt a file. That is a cross-platform way of doing it. You will note that the libs plus equal, this is not the cross-platform way of doing it. I'm going to get some fan mail about that, I'm sure. So let's review real quick before we end this tutorial. First thing you've done from part 1 is you've compiled the bottom libraries, copied the DLLs and A files into the directory, and then we set up our include path. These are where the headers are, and you set up the lib path, and then we set up our includes, which bottom.h is really all you need to include to use the bottom framework, or I should say the bottom library, using qdebug, and then we're using some standard type library includes using the namespaces. And then let's jump down here and let's explain this a little bit better. We've got our QCore application. That's nothing new. We got debug, nothing new. We're setting up some strings here, and we're saying these are the locations of the files. We're using the bottom library initializer. This is how bottom runs. It needs this before you can do anything with bottom. Otherwise, it just simply won't work. You really need to read the bottom documentation to understand all that. Setting up a passphrase. We're setting up an auto-seed random number generator. That's what RNG stands for. And we're setting the string to key, and we're deriving the key from our password. Iterations, that's part of the salting. Let's see here. Secure vector. We are creating a combination, and just, we're taking our password, jumbling it around a little bit, making it a little more secure, and then we're making a symmetric key. Remember, a key is like sticking a key in a lock. You need that to encrypt and decrypt. The initialization vector we're deriving from the key and the IV, and then we're just simply encrypting and decrypting. And when we go into these, you need an input stream. Remember to set it to binary mode, otherwise it's going to use the escape characters. And then we are creating a pipe. A pipe is a bottom standard, or a bottom convention, and we're saying, okay, encrypt using AES 256, and there's our encryption flag. There's our key, there's our initialization vector, and we're saying new data sync stream, and we're sending it to the output file. And then in our pipe, we're starting the message, we're reading the data in, and then we're ending the message. That actually does the encryption. That's where the bottom library does the encryption right there. Then we're flushing the output file and closing it, and closing the input file. Whew, what a tutorial. Pretty complex, pretty advanced tutorial, but I think you understand it. And if you're really wondering how to do the seed, let me actually just create a new one. Void main2. I actually did create the initial program using the seed, and let me show you what that looks like really quick here. And you can see I've got some other files set up, and this is pretty much the same source code, but you would quite literally just set the new random salt using the string to key, and that's where you take your random number generator, and you're using 8 octets, and then you're saying secure vector byte, and you're saying this salt right here, string to key current salt. So what you're doing is you're creating a salt. That way, if you have a password of password and you use that password twice, it'll never be the same because you're salting it, you're changing it. Like I said, encryption is a science in itself. Using a string, essentially what you're doing is you're using SHA-256, you're creating a hash. And what a hash is a numerical representation of data. The problem with hashes is there's something called a birthday attack, meaning you'll have a collision. Two hashes for two different passwords can collide and be the same. It's called the birthday attack because you'd walk into a bar and there's a certain percentage chance that somebody else in that bar will have the same birthday as you. And there's a greater chance that two people in that bar have the same birthdays. It's actually called a rainbow table or birthday attack, where you create a huge list of hashes and you start throwing hashes at this until you break it, so somebody could actually decrypt your data. Now that goes back to the strength of the algorithm that we're using. We are using the AES 256 block cipher, and we're using it in cipher block chaining mode. Now AES is the Rindell block cipher. Advanced Encryption Standard is what that stands for. 256-bit. That's stronger than most of the applications you're using. Let me just put it this way. It would take a very, very long time for somebody to break that encryption. But you have to use the encryption correctly. And that's where we go back down into these keys, initialization vectors, and salts. If you don't use a salt, your encryption is inherently weaker. And the Botan documentation, which I encourage you to read, explains all of this in very, very simple details. And he actually says, do this because of this, do this because of that. So, really running out of time. This tutorial's kind of mushroom clouded into something much bigger than I wanted it to. But killing two birds with one stone. This answers the user feedback of how to use a third-party DLL and how do you encrypt a file. And if you've sent me user feedback asking a question, I'm sorry, I have much more user feedback than I have time. So bear with me. I'll try to get to it eventually. This is Brian. Thank you for watching. I hope you found this educational and entertaining.